Hello friends, welcome to Best Tutor. This is Rama Vishwanathan. In today's video, we are going to learn one very important concept, an interesting concept of circles, angle properties of a circle. What is this angle property? And we are going to learn about one angle property of a circle here. Angle property. What is this angle property of a circle? In a circle, infinite arcs can be drawn. I consider one arc and I am going to consider the center of the circle. If I join these two, I am going to get two radii, and this is the angle subtended by the arc AB at the center of the circle. I consider an arc AB. This is the arc AB. This arc AB subtends an angle X, for example, at the center of the circle. Right. What does it mean? Angle subtended by the arc at the center. I am going to consider the end points of the arc and I am going to join these 2 points to the center. I get two radii and they are going to be inclined. That is the angle made by the arc at the center. Similarly, can this arc make any other angle? May not be at center, maybe on the circle. Yes, isn't it? It can make an angle at the at any point on the circle. Right, at any point on the circle. Now the statement of the theorem is angle made by an arc at the center of the circle is twice the angle made by the same arc at any point on the circumference of the circle. Right, I repeat the statement, angle made by an arc at the center of the circle is twice the angle made by the same arc at any point on the circumference of the circle. So if this is x, this will be x by 2, right? If I consider angle arc AB, I am going to consider the other part of the arc AB, not on AB. I am going to explain it how. Right? Now, there are three possibilities here. Let us consider one after the other all the possibilities. I consider an arc AB. This is the center. We drew the radii and this is the angle made by this arc AB at the center. How am I going to prove that the angle made by the same arc AB at any point on the remaining part of the circle? Say for example, this is D or C, whatever it is, and then this angle is twice, this angle is twice the angle. If this is x, this is 2x. This is to be proved, right? How are we going to prove it? We need to make a small construction here. Let us understand what is given, what is to be proved. Then we will consider the approach. I will do a small construction here. I am going to join DO. That is going to be a radius. OA, OB, OD are the radius. Now I am going to extend it. Let this be C so that I can mark this point as D. This is not touching the circle. It doesn't matter even if it touches the circle or extends the circle, doesn't matter. Right. Now we have AB as an arc. AOB is the angle made by this arc at the center. ACB is the angle made by the same arc at any point on the remaining part of the circle. We need to prove that angle AOB is twice angle ACB. RTP is required to prove. Angle AOB is twice angle ACB. We have two more possibilities. Is it necessary that this angle made by this arc on the remaining part of the circle be above this way, and it can be here, it can be in the same arc, isn't it? We are going to deal with those separately. Now, I have joined CO and extended it to D. Now, consider triangle OAC, only triangle OAC. Let us draw it separately. It's going to be like this, OAC. This is A. This is C, this is O, this is D. We have extended this line, right? This is C. Now, in earlier videos where we have learned about the basics of triangle, isosceles triangle, if we consider an isosceles triangle, angles opposite to equal sides are equal, right? This triangle, OC is the radius of the circle and OA is the radius. So, these two parts are equal. These two sides are equal, I mean to say. When two sides of a triangle are equal, then the angles opposite to them will be equal. Let this be x, let this also be x. right? If this is x, this also will be x, because angles opposite to equal sides are equal. Now this is a triangle, OAC is a triangle. Don't you consider that, don't you think that this is an exterior angle? This is an exterior angle of this triangle, and we know that exterior angle of a triangle is always equal to sum of its two interior opposite angles. The angles OCA and OAC are interior angles which are opposite to this angle. So exterior angle is equal to sum of its two interior opposite angles. So this angle will be equal to x plus x, which is going to be 2x. So this part is going to be 2x, where this part is equal to x. Observe carefully, I have related these two. I have just taken only a part of this figure, drew it separately. This is an isosceles triangle. So the angles opposite to equal sides are equal. So on that basis, these two angles I have considered to be x. They are equal. So I have considered to be x. And this is an angle which is exterior to the triangle. Exterior angle of a triangle is equal to sum of its two interior opposite angles. So angle AOD is equal to angle ACO plus angle CAO, that is x plus x, which is 2x. Now let us consider the other part, other side of the triangle. We are going to apply the same concept over there, right? This is O, this is B, this is C, and this is D. OC is equal to OB because they are radii of the circle. So let me assume that this angle is y, then this angle also is going to be y, because angles opposite to equal sides are equal, these two are equal because they are radii of the circle. Angles opposite to equal sides are equal, so these two angles are equal, right? Perfect. Now this angle is the exterior angle of the triangle, and just now we have learned that exterior angle of a triangle is equal to sum of its two interior opposite angles. So this angle will be equal to y plus y, that is 2y, right? So in this figure, let me mark this as 2y, right? If this is 2 and here it is y. Now angle AOC is equal to x, angle BOC is equal to y. Now angle ACB is equal to, this is the angle which I require, AOC, ACO, I am so sorry, notation is very important. Angle ACO is equal to x and angle BCO is equal to y, angle ACB is equal to x plus y. This angle is x plus y. Now similarly here, angle AOD is equal to 2x, angle BOD is equal to 2y. Now this is 2x, this is 2y, so total angle is going to be 2x plus 2y. Angle AOB is equal to 2x plus 2y, or 2 into x plus y. But x plus y is nothing but angle ACB, 2 times angle ACB. Hence we have proved that AOB, angle AOB is equal to 2 times angle ACB. Quickly I will repeat the concept. Here in the same theorem we have 3 possibilities. I am going to deal with the remaining possibilities in the coming videos, right? Let us understand each one after the other in detail. We are given a circle. We are given a center of the circle. AB are 2 points on the circle, or they are going to be an arc of the circle. Now the statement of the theorem is, angle made by the arc at the center of a circle is twice the angle made by the same arc at any point on the remaining part of the circle. That means angle AOB is twice angle ACB. How am I supposed to prove? I have joined C to O and extended it a little bit to D, and I have considered these two triangles separately, and triangle ACO I have considered separately, triangle BCO I have considered separately. Both are isosceles triangles because AO and BCO are the radii of the circle. So OA is equal to OC, therefore angles opposite to equal sides are equal. I considered OAC is equal to OCA is equal to x. Then we made use of one simple property of triangle, that is exterior angle of a triangle is equal to sum of its two interior opposite angles. So this angle is going to be 2x. Similarly, I considered the other part of that and I proved that angle BOD is equal to 2y. Now we have written all the notations clearly. Angle ACO or ACD, whatever it is equal to x. Angle BCO or BCD is equal to y. Therefore, angle ACB is equal to x plus y. Now angle AOD is equal to 2x, angle BOD is equal to 2y, therefore angle AOB is 2x plus 2y, that is 2 into x plus y. But x plus y is nothing but angle ACB. Therefore angle AOB is equal to 2 times angle ACB. Right? This is a theorem, proof of the theorem, where the angle made by the arc at any point on the circumference of the remaining part of the circle is like this. We have 2 more possibilities which we are going to learn in the coming videos. Right? So this is the theorem we have learned in this video. Thank you.